We're going to be working through 7-6 today. So please pause the video, work through the bell ringer questions here, and then resume to see the solution. So for the first one here, I have 13xy cubed, and I have 20x squared y squared z. So this is a prime number, and this breaks down. So you might want to try to break things down like normal, but if there's not a 13 in here, then you know it's kind of pointless. Okay, so I'm just going to take 13 times 20, and this is where it actually works out kind of nice. So 260 is my common number, and then I look at my variables, and I take the highest power of each one. So I'll have x squared, and then I'll have y cubed, and then I will have a z. So that is going to be my least common multiple for A. For B, I need to simplify those. So I know that I'm going to have a 5, I'm going to have an m, and I'm going to have a p. So that is my common denominator, and I just multiply by what's missing. Okay, so I need to multiply by a 5 on this one, I need to multiply by a p on this one. And then once I do that, I know that my denominator will be 5mp, and then I just fix my numerator. So that'll be a 15 plus 4p, and it might be best to write it with the variable first, but not super important. Okay, so that is my solution for B. For C, you're going to want to factor first. So this factors, we take out a 2, we're left with x minus 6. This factors, we take out a 3, and we're left with x minus 6. So really the only thing we're going to be looking at is the 2 and the 3. So what's a common denominator with the 2 and the 3? We know it'll be a 6. And then I need to have that x minus 6 as well. So this is my common multiple or common denominator. That's what's going to be on the bottom when I'm done. All right. So then I need to multiply this by a 3. So let's get that common denominator. So I'll take 3 times this to get the 6. I got to multiply on top and bottom. So I'll put that in parentheses. Take this times the 2. Multiply that on top and bottom. Okay. So we're going to have to distribute here. 3x plus 15. And then here we have a subtraction. So I told you guys yesterday we want to take that through there. So we're going to take this negative 2 through here, and then that will give us negative 2x minus 4. And then we're just going to combine like terms, okay? So we'll have 3x minus 2x is just going to be an x, and then we'll have 15 minus 4, so it'll be x minus 9. All right, so that is our solution for C. So for the next part, I wrote out some homework questions to work through. These are the 6 that I chose that I figured you might have some questions on. So we're going to work through these 6. If you would like to speed up or skip some of them, you can do that. All right. So between these ones, we have 24, 40, and 15. These are the ones where you're going to have to factor tree them. So 6 and 4, 3 and 2, 4 is a 2 and a 2. Let's factor tree this one. So 4 and a 10. And that'll be a 2 and a 2, and that's a 2 and a 5. And then this will be a 3 and a 5. So we want the highest power of each individual number. So with this one, we can get 2 to the third. With this one, we can get 2 to the third. So we need 2 to the third, which is going to be an 8. Okay, I'll just write that off to the side over here. I have a 3 that I'll take out of here. So this has a 3, this has a 3, so I know I need one of those. And then this has a 5, this has a 5, so I know that I need one of those. So this will be 8 times 3 times 5, or 8 times 15, which is going to be 120. So that's the number that we're looking for between those 3. And then we pull out the highest power of each variable. So we have an a squared that we're going to need, and then we have a c. Let's do b next. We got a b there. So we need one of those. And then we have a c cubed. And then the highest power of d, we have d to the fourth, and we have d to the third, so we're going to need d to the fourth. So that is my least common multiple of those 3. Okay, on to the next one. We're kind of going to have to do the same thing here. So between 15 and 35, we're going to have to figure out a number they both go into. Okay, so with this one, it might be best just to kind of keep adding 35s and then see if 15 goes into that. So it looks like 105 will be the number. Okay, So 35 plus 35 is 70. 15 doesn't go into 70, so let's do another 35, which is 105. Okay, and that's 15 times 7. Okay, so that works out nice. And then we're going to need to look at our variables. So we're going to have x to the third, y to the fourth, and then z. So that's our common denominator. We need to multiply by that, or by things to get there. So we need to get that 105 x cubed y to the fourth z on the bottom. So this one, we are going to take that times 7. Okay, so we need a 7. That'll get us to 105. And then we have the x's taken care of. We need 2 more y's, so y squared, and then z. So that's what I have to multiply top and bottom by, 7y squared z, in order to get that common denominator. Over here, we're going to take 35 times 3. So we're going to be multiplying this one by 3. We need an x, and we have the y's, and we have the z. So all we're taking over here is the 3x. All right, so 7 times 4. So now we're just working on the top here. We know that the bottom is going to be this common denominator, so we can write that out, I guess, if we wanted to. 105 x cubed y to the fourth z. And then the top, we're just going to multiply those and subtract. So it'll be 7 times 4 is 28, and looks like we're just going to have a b y squared z, and then the other one, so minus 9 bx. So we can't really subtract anything here, and we cannot simplify anything, so this is our solution. All right, 31. So factor the denominators here, figure out your common denominator. We'll have a 2x and then an x. And then we need a 3 and a 2 or a 6 and 1. Since that's 11, if I put a 6 there, that'll get me a 12 when I multiply those. So that's probably the combination that we want. Positive 12, negative 1, that'll get us to that combo. Over here, 2 numbers to multiply to an 18 and add to a 3. So that's going to be x plus 6 and x minus 3. All right, so then we need our common denominator. If we wanted to, again, you can just kind of write that off to the side. We will need a 2x minus 1. We're going to need an x plus 6. And then we're going to need an x minus 3. So we need all 3 of those. And it looks like there's only one missing from each one. So this one, we're missing the x minus 3. That's the binomial that we have to add to get those 3 on the bottom. Then over here, we're missing the 2x minus 1. Okay. Then we're just going to multiply across the top. Let's switch back to red. So that goes through there. We'll have 6x minus 18. And then minus, if you want to do that, add a line, change a sign thing. It'll be minus 16x plus 8. And then we're just going to combine like terms here. So 6x minus 16x, that's a negative 10x. And then negative 18 plus 8, that's a negative 10. And you always want to check to see if you can simplify anything like this. But if I took a 10 out here, which I could, I'll just have x plus 1, which doesn't really get us anywhere. So this is good enough. Okay. So for number 34 here, it was a word problem, and it had this equation in the word problem. So you had to just simplify that as much as you can. When you run into something like this, and there's just a 6.5 there, remember there's a 1 down there. So your common denominator is going to be that t squared plus 36. So I just do t squared plus 36 on the top and the bottom. And then we end up with something like this. So then we want to simplify where we can. So this right here turns into 6.5 t squared plus 234. That's when I distribute that. And so I'll just add this with that now that I have a common denominator. So on the bottom, we have t squared plus 36. And on the top, we have a 6.5 t squared. We have a 20.4 t. And then we have a 234 on the back end. And then that is the solution. And then for part B, I can't remember specifically what it says, but it's like, what's the value after 30 minutes? So you can plug the 30 into all of your t's here. That's kind of a little extra, so I would just go back to your original one, plug in the 30 here and here, and then add 6.5. So if we do that, it would be like 20.4 times 30 over 30 squared, which is 900, plus 36, and then plus 6.5. Whatever that bit comes out to be in your calculator, which is 7.15. Yep, so 7.15 is what that ends up being. So I just plugged in 30 to my original problem, because again, like I said, you could plug in 30 here if you wanted to, and you're just going to be plugging it in a little bit more, maybe a little bit more work in your calculator, so it might just be best to start with this one. Okay, 38. So this is a complex fraction. We didn't get to look through a whole lot of these in class yesterday, so if you didn't understand 37, this will help you with that one. But what you have to do is simplify on the top, get those together. Simplify on the bottom, get those together, and then you're going to skip, flip, and multiply, because really this is division. Okay, so let's give it a shot here. Okay, so it's fairly straightforward. This one is missing the 2x minus 1, and this is missing the x plus 6. All right, so we're just going to do that. 2x minus 1 over here, and then x plus 6 over here. And then those will combine. You're going to have the x plus 6 and the 2x minus 1 on the denominator there. And let's change our colors here to multiply that through. So that's going to be a 10x minus 5. I'll write that off to the side here. And then minus, so add a line, change a sign. So minus 2x squared minus 12x. So I combine these, that goes on the numerator. Okay, so I'll have a negative 2x squared, and then I have a 10x minus 12x, so it's minus 2x, and then I have a negative 5. Let's fix that x there a little bit. So that's the top. And then on the bottom here, we kind of do the same thing. I need an x plus 6 here. X plus 6 here to get the common denominator here, and I need a 2x minus 1 here, 2x minus 1 here. Okay, and then again on the bottom, our common denominator will be that x plus 6, 2x minus 1. And we're just going to multiply through the top here. So boom, boom. That'll get me x squared plus 6x, and then boom, boom. That gets me to an 8x minus 4. So my numerator will be, we're going to have an x squared, positive 6, positive 8, so that's positive 14x, and then minus 4. Okay, last step. You're going to skip, flip, and multiply. So I take the bottom one, I move it up, and I flip it. And then you should see that that denominator is going to cancel. So that cancels with that, and I have this over this for my final answer. Okay. And occasionally these will continue to simplify here. This one doesn't, because there's no way I can get a smile method to get my middle number of a 2x, and there's no way I can multiply to get a 4 and then add to a 14. So you are done with that one. So they take a little bit of extra work because you're combining here, and then I'm multiplying. So it takes a little bit of extra effort. Let's check out 49, and that'll be the last one. Okay. So you start by factoring as much as you can. This is the only thing that you can factor, the x squared minus y squared. There is no sum of squares, right? There's only difference of squares. So x minus y, and then x plus y. Then you should see pretty plainly what you need for a common denominator. Over here, I'm missing the x minus y, so I need one on the bottom. one on the top. Over here, missing the x plus y. Same thing, one on the bottom, one on the top. Okay, my common denominator then is just going to be x plus y, x minus y. So from here, I'm just working across the top. So I'll do add a line, change a sign there, multiply everything out as much as I can. Okay, and then we'll just combine like terms. So this one is going to be xy minus y squared. And then this one here is going to be a negative x squared minus xy. Okay, and here I just have the x squared, y squared. All right, so if I combine like terms, I have x squared, and then I have a negative x squared. So those actually cancel out. I have a y squared and a negative y squared. Those are going to cancel out. Okay. And then I have xy minus xy. So those cancel out. So everything worked to subtract themselves on the top. And so you get a 0 in the numerator. Right? When I subtract everything, I get a 0. And on the bottom, I have x minus y, x plus y, but that doesn't really matter because whenever you have 0 divided by something, your answer is always 0. Okay, so this is the answer. Big old donut. So that was your homework. Those are the questions I figured that you had. Okay, that was 6 of them. That was a good chunk of your homework. Please turn in your homework and we will move on to the lesson. Okay, so today we are going to cover 7.6, which is solving rational equations and inequalities. The solving rational equations should seem very familiar because it's kind of what we did in the previous lessons. And inequalities are going to be the ones that are a little bit more involved. Okay, so these are the harder ones here. But it should seem very familiar from what we did the other day. Okay, so starting out 7.6, we're going to work with solving a rational equation. So that's a rational equation down here. It's just an equation with variables and fractions. And we have 3 steps to do this, okay? First one, you want to find the least common multiple between all fractions, just like we did yesterday. And then now we want to multiply everything by that least common multiple. And then, once you multiply everything by that least common multiple, you're going to cross-cancel as much as you can and solve for x. Okay? So if we think about, we had equations like this before, where we had 2/3 x plus 3/4 is equal to, let's say, a 1/2. What are you going to multiply everything by here to get rid of the fractions? We got a 3 and a 4, that goes into 12. So I would multiply everything by 12 and then cross-cancel to see what I have left to multiply with. This is exactly the same topic, but now we have variables involved here. Okay? So let's check out the first problem. And I have a note here that says check your solution because sometimes you're going to get a value. So say we ended up getting a 3 as a solution here. If I plug a 3 in right there, that would be 3 minus 3, which is 0 in the denominator. So that would be undefined. Okay? So you do not want to get a 3 here. You want to check your answers. So between a 24, a 3 minus x, and a 4, what is the common denominator? Okay, well, let's just look at the numbers here. When you see a minus or a plus in the bottom, you want to think of that being a binomial or something in parentheses like that. That's a group, okay? So really the numbers you're looking between 24 and 4. So 4 does go into 24, so we're going to write that LCM off to the side here. We're going to need a 24, and then we're going to need a 3 minus x, okay? That's what our denominator needs to be. Okay, so now if I multiply everything by the 24 times 3 minus x, okay, I'm going to multiply everything by that. So when I look at multiplying this fraction by this, and you can put this over 1 if you want to, you look at what's going to cancel between the numerator here and denominator here. 24 would cancel, so I would have just the 3 minus x left that's going to multiply by the 5. So when I take this into my first term here, I would be left with 5 times quantity 3 minus x. Okay? Now I take it into the second one. So what's going to cancel now when I take this times this? You should see that the 3 minus x would cancel, and I'd be left with the 24. So I'll have 2 times 24. And then for the third one, so right here to here, I have 24 times 3 minus x. This one's a little bit harder to see because it's not straight up one thing that cancels. So I'll write that over here so we can kind of see it. If I'm multiplying this times this, the 4 and the 24 are going to cross cancel. So that would turn into a 1. That would turn into a 6. Okay, because I actually have to cross cancel those there, just like normal fractions. Like as if I were doing it here, I had to cross cancel with the 12. Okay, so I'd have a 1 times a 6 times the 3 minus x, which is just 6 times 3 minus x. So after I multiply everything by that common denominator, all I have left is this. I got rid of my fractions. Okay, so I just simplify this when I solve for x. Okay, another way that you could do it if you're not fond of this multiplying the fraction part is you get a common denominator across the board. Okay, let me show you here. I just work through these. Let me get rid of this here. So we're going to work through this to get a common denominator. So over here, I got a 24, I need a 3 minus x. So take top and bottom by 3 minus x. Okay, over here I got the 3 minus x, so I need to take it times the 24. Take it times the 24. And then over here, I'm going to have to take this times 6 times 3 minus x. 6 times 3 minus x. Once I get that common denominator, the denominator would actually end up canceling out because this is an equation, and I would be left with this on the top, which is exactly what we have here. Okay, so let's go ahead and finish this out and see what we get. So we're going to take that 5 through there, and we're going to get a 15 minus 5x over here. 2 times 24 is a 48. Then on the other side, we'll take the 6 through, so we have 18 minus 6x. Put the x's on the same side, so move this over. Okay, so that just gets me to an x over there, and I probably could have combined these before I did that, but 15 plus 48, that's going to be 63, and then equal, we just have the 18 left over there, so minus 63 on both sides. So 18 minus 63, that's going to be a negative 45. Okay, we didn't get that 3, so we're good to go. If I plugged in a negative 45 here, that would end up working. Okay, so this would be 3 plus 45, which is a 48. So 48 is the multiple of 24, so you can kind of see that that's probably going to work out. Okay. So let's try another one here. Let's see if you can try this one on your own. So please write the problem down, pause the video for about a minute to 90 seconds, and then start it up for the solution. All right, so my common denominator here should be pretty straightforward. I need a 2x minus 1. That's what I need for a common denominator. Okay, so this one is probably more simple, just to get a common denominator and then cross it off. Okay, so here we need x minus 1 on top and bottom. And then here we need the 2. And then here we need the x minus 1 again. Okay, so then once we get the common denominator, forget about the bottom. And then we're just working with the top. So this will be 5x minus 5 plus 6 is equal to, distribute the 1, which doesn't change much, is equal to x minus 1. Okay, so simplify this down a little bit. 5x plus 1 is equal to x minus 1. Move the x to the left. We have a 4x. Move the 1 to the right. Is equal to negative 2. Divide by 4. And we get our fairly decent solution of a negative 1/2 after we simplify. Okay, let's try one more of these. So go ahead and try this one as well. This one's got a little bit more to it because you see that we have this trinomial that you're going to factor, and more than likely we're going to end up with an x squared in the numerator. Okay, so pause the video and give it a shot. Okay, so on this one here, we're going to factor it. I need an x minus 4, actually x plus 4, x minus 2. That's what that factors to. Okay, so you can see that this is going to be your common denominator. So over here, we're missing the x plus 4. X plus 4. And then here, we're missing the x minus 2. Okay, and then here, we have both of them, so we don't have to do anything. So we got those common denominators, forget about the bottom, and we're working on the top. So x squared plus 4x is equal to 2x minus 4. And then that negative or that subtraction sign goes to this. So minus 2x. All right, so let's simplify down a little bit. X squared plus 4x is equal to, so that 2x minus 2x goes away, and we just have a minus 4. So I have an x squared and an x in my equation. That means I'm going to have to factor. So let's move this over to the other side, set it equal to 0. And factor. So x squared plus 4x plus 4 is equal to 0. So what two numbers multiply to a 4 and add to a 4? That's a 2 and a 2. X plus 2, x plus 2 equal to 0. So you don't have to write your answer out twice. You get an x equals negative 2. That's called a double root. Okay. Now, you want to make sure you check everything. So if I put a negative 2 in there, I get a negative 4, and it works okay. So really, when you're checking your solutions here, you're looking to make sure that you don't get any zeros in your denominators, okay? If we had a positive 2, it wouldn't work. But since we have a negative 2 for our solution, it works for our equation, okay? So let's take a quick break here. We did not get to this in class yesterday or the day before. You need to track your previous test scores, okay? So this would be the chapter 6 test. That's the logarithm one. So open your notebooks or your binders, and you're going to track your test scores on your sheet that I give you guys. Open up Power School. You can use your computer here for a minute. You can open up Power School, find what you got, and track it on your sheet. Okay? So on to the next thing. We want to, this is another one. I'll come back to this if we need to. But this one really, it's kind of like one of the examples from the homework. You got to have this over 1 in order to multiply this one through. Okay? And you'll end up having some things cancel out. But let's jump on to solving rational inequalities. So I have these 4 steps here. Okay? These are in your textbook. You can write them down if you want to. I'll read through them. So if you want to write them down, please pause the video, write them down, and I'll go through them step by step. So step 1, you're going to state the excluded values. Okay? So what that means is what is going to make the bottom 0. Okay? Denominator. So what is going to make the bottom a 0? So the denominator cannot be equal to 0. So what is going to make that equal to 0? You want to list those off to the side. Okay? Then you're going to solve the related equation. So what this means when I say related equation is just change it to an equal sign. We're going to come back to the inequality sign later on. So switch it to an equal sign, and then we'll come back to inequalities later. Step 3. Use the values that you got from step 1 and 2. So whatever I have from this one makes my denominator equal 0. And then whatever I have from my related equation. So this is going to be an answer. I'm going to use a number line and write these numbers on a number line. Okay? Then I'm going to test values in between all of those numbers to figure out which intervals work for the inequality. Okay? These are kind of involved, so it's important that you follow step by step. Okay? So for this first one here, it doesn't really look too bad if this were just an equal sign and we had to solve it. Okay? So let's list our excluded value first. All right? So we can't have a 0. So that's a number that's going to go on the number line. After we list the excluded values off to the side, there could be 1, there could be 2. I think that's as many as I would give you. After I list this off to the side, I'm going to rewrite this as an equal. Okay, so I'll come back to the inequality later. And then I'm just going to solve it. So what do we need for a common denominator? So this is just like the other problems. So I have a 3, a 9, and a 3, so I know I'm going to need a 9, and I'm going to need a k. Okay, so that's my least common denominator here. So let's do like we've been doing, multiply by the missing pieces, and then just cancel out the denominator. So here, I need a 3, because I have a 3k down there, right? Because that would turn this into 9k. I have a 9k there, so I don't need to multiply that one by anything. And then here I have just a 3, so I have to multiply this one by a 3k. Okay, and then forget about the bottom. We're working across the top. So 3 plus 2 is equal to 6k. Go ahead and solve that one. So we'll have 3 plus 2 is 5 equals 6k. And then divide both sides by 6. We get k is equal to 5, 6. Okay. So you will end up with fractions sometimes. We have this one right here. Okay, we got k is equal to 5, 6. So now we need to put this on a number line, and we need to put this on a number line. All right, so let's draw our number line, and let's put 0 here. And 5, 6 is really close to 1, so I'll put 1 there, 2 there, and let's make our, let's say 5, 6 is going to be there. Okay, and so I have, what I'm going to do is draw lines or intervals here. So I have an interval on 5, 6, and I have an interval on 0. Okay, so I need to figure out if this side works when I plug stuff in. So now we're actually going back to the inequality. So I need to plug in something from here, plug in something from here, and plug in something from here. And really the values don't matter. It's a value that makes your life easy when you plug them back in. So let's move this stuff out of the way, and we're going to use our original inequality here. Okay, so what value do we want to plug in here that's less than 0? You pick something easy. Okay, so let's try x equals -1. You pick something easy. -1 is going to be as simple as we get here. We also, if you see a nicer one, what's something that we can use to cancel out with the 9s or the 3s? Okay, you could use a 1/3, but for now, let's just use a -1. Okay, and for this one, I'm going to use a 1/3 so I can show you how that would kind of work in your favor a little bit. And then out here, the easiest one to pick would probably be a 1. Okay, so these are test values, or what we're calling them. We're going to plug these into our inequality to see if they work. If one of them works, then that interval is one that we're going to have for part of the solution. Okay, so I'll show you what I mean after we plug stuff in. So let's plug in the -1 first. And let's do our work in blue here. So 1 over, if I plug in a -1, that makes it a -3. So it's -1/3. And then plugging in a -1 to this one, minus 2/9, is that less than 2/3? So sometimes you have to actually figure these out or simplify them. This one, you have two negatives being put together, so this entire side will be negative, which is obviously less than 2/3. So yes, this interval works. Okay. Now let's try the 1/3. So let's pick a different color for that one. So 1/3 getting plugged into there. So 1 over 3 times 1/3 plus 2 over 9 times 1/3 is less than 2/3. Okay, so I picked a 1/3 because you can kind of see what happens here. And I could have picked a 1/9 even if I wanted to. That might have worked a little bit better, but let's just go with this one. So 3 times 1/3, that just turns into a 1. So this is 1. And then 9 times 1/3, that turns into a 3. So this is 2/3. And then that stays as 2/3. So again, this one you don't really have to add or subtract the fractions. You just kind of think about it. So 1 plus 2/3 is less than 2/3. No, because this is 1 2/3, which is obviously more than 2/3. That doesn't work, so this interval is out. It doesn't work as part of our solution. Okay, And then let's try this one, x equals 1. So I'll do that one in green. Okay. 1 over 3 times 1 plus 2 over 9 times 1 is less than 2/3. So 1/3 plus 2/9 is that less than 2/3. This one you're actually going to have to see if it works. Okay, so you can add your fractions here. If you wanted to make your life a little bit easier, you can do just like we did in the beginning to get rid of the fractions. Take everything times a 9, and then you should see what we get after there. So if I take this one times a 9, 9 times 1/3 is a 3. Take this one times a 9, that's a 2. Take this one times a 9, the 3 and a 9 cross cancel to leave me with a 3 times 2, which is 6. Okay, so this is 5. Is 5 less than 6? Yes. So that's another interval that works for our solution. Okay, let's do that in blue. Okay, if you don't like the way I did it here, then just add this in your calculator, 1/3 plus 2/9, and then write down the decimal, and then less than, so this is 2/3, which is 0.67, which you can get in your calculator again. Okay, so this interval is good, so what I'm going to do is I'm going to draw a circle, and I'm going this way to show that I want that interval, and this interval is good, so I'm going to do the same thing. Draw a circle. I'm going that way because that is covering the interval that I tested, right? So I tested -1 because it was left of 0. I tested 1/3 because it was in between 0 and 5/6. And I tested 1 because that was right of 5/6 or greater than 5/6. So now I just need to make an inequality that represents my little arrows that I drew. So those are that's on 0, where your interval starts. So I'm going to have x is less than 0. Or, okay, because they're going opposite directions, or x is greater than 5/6. That is your final answer. The 0 comes from this interval, the 5/6 comes from this interval, which came from our starting solutions. Okay, so these are pretty involved. You have a lot of steps to do these. Okay, so we're going to do one more of these, see if we can make some sense of it. Okay, it's going to be similar to the first one. So think back to what our steps were. Step 1, list excluded values. So I have an x and an x. X cannot be 0. That's an excluded value because if I put a 0 in there, then I would have an undefined value. Okay, next, I want you to see if you can solve this to get your next value. Okay, so pause the video for about 60 to 90 seconds, solve it, and then come back and check to see if you got your answer correct. Okay, so this one, our denominator is going to be a 5x. That is going to be the one that tells us what our denominator is. So we need a 5 here, a 5 here. We need an x here and an x here. And once we get those common denominators, forget about the bottom. Okay, and remember at this point in time, we're not really working with that. We want this to be an equal sign because that's going to be the related equation. So on the left, I'll have 5 plus 3. On the right, I'll have 2x. 5 plus 3 is 8. And then divide both sides by 2. So you get x is equal to 1/4. Okay, I have my two values to put on a number line. So let's draw our number line. We have a 0 again, and let's do halves this time. So 0.5, 1, 1.5. And the way I did this doesn't really matter. You could do 0, 1, 2, 3, whatever. I just did this because it's going to make my number line a little bit smaller. Okay, so I have x cannot be 0. So I have an interval at 0 from this one, right? And then 1/4, which is 0.25. So that would be right there. Okay, so this would be 1/4 from this. It comes from this one. All right, so now we need to list the things that we're going to check. So left of 0, let's try x equals -1. In between here, so what's in between 0 and 1/4? Okay, well, what's going to work nice here. So what's smaller than 1/4? All right. 1/5 is actually smaller than 1/4. Okay. 1/4 is 0.25. 1/5 is 0.20. Okay. 1/5 is actually going to work a little bit better with this one. It might not work very well with this one. Okay. But you could pick a decimal if you wanted to and just try it. It doesn't really matter. Since I'm doing this without a calculator for the most part, I'm going to say is x is equal to 1/5. That's the value I'm going to try in here. And then out here, to make your life easy, just go with the 1. All right. So I'm testing this value, I'm testing this value, and I'm testing this value to see if they work in this inequality. All right. So plugging in the -1 to here. So it's 1 over -1, which would just get me a -1. And then I have 3 over 5 times -1. So that would be a -3/5. So let's change this. So -3/5 is less than 2/5. So just like the last one, these are all negative. That's a positive. This one's going to work. Okay. Now let's try the 1/5. So 1 over 1/5 plus 3 over 5 times 1/5. Is that less than 2/5? So 1 over 1/5, remember how this works. Skip, flip, multiply. So this will be a 5. That turns into a 1. So it's 3 over 1. Okay, so is 5 plus 3 less than 2/5? No. That one's out. And then let's try our last interval here. So we're plugging in a 1. So 1 plus 3/5. Is that less than 2/5? And this one does not work either. Okay, because that's 1 3/5. That's definitely not less than 2/5. So really the only number that worked was the -1, which came from the 0 interval. So left of the 0 interval. So if this works, I'm going to draw my little bubble there. We're going to the left. And so what is the inequality that represents that? X is less than 0. So if we plug in values less than 0, that'll work here. Anything that is equal to or greater than 0 will not work. Okay. So again, these are kind of involved. Definitely come back to this video if you need it to figure out how to work through these. But I will be looking for this amount of work. I'm going to be looking for excluded values. I'm going to be looking for your solution, your initial solution. I'm going to be looking for a number line with intervals drawn and tested, and then I'll be seeing that your final answer is some inequality that is representative of your number line. Okay. The last couple questions here are word problems, and I gave you a few word problems on your homework. Okay. This was in some things in physical science. So we got distance equals rate times time, and we can rearrange this for time if we want to. So just divide by r, and we get something like this. Okay. So let's read this quick, and then I'll show you how to set it up, and then you should be able to solve it after I show you how to set it up. So Lilia swims for 5 hours in a stream that has a current of 1 mile per hour. Okay, so there's a time, and here's a rate, 1 mile per hour. Okay, she leaves her dock and swims upstream for 2 miles and then back to her dock. So she goes up 2 miles and then back 2 miles. So the distance is equal here. What is her swimming speed in still water? Okay, so we need to figure out her rate. We know the rate of the current, all right, and we know how long she swam. We need to figure out her rate. So we're going to be using this one because the time is equal to 5. Okay, the total time is equal to 5. So we're going to have a distance over rate going upstream, and then we're going to have a distance over rate going downstream, which is equal to my total of 5 hours. Okay, now this isn't going to be just an R because we're going to have her speed with the water speed and her speed against the water speed. Okay. The distance is the same, 2 miles up, 2 miles back. Okay, so when I actually set this up, it looks like this. Okay, so take a little bit here to look at this, and I'll read through it. So this would be my first one. So that would be like, this would be going upstream, which means the stream is pushing against us. So it's going to be her rate minus the water speed, okay, plus, again, 2 miles, her rate plus the water speed. So this would be going back with the current. And this is the time going against the current, which is kind of backwards because you want the speed will take away when you're going against the current, and the speed will add when you're going with the current. Okay? And that equals your total time. So then to solve this, you're just going to get your common denominator of r minus 1, r plus 1. So r plus 1, r plus 1. Okay? And you should see how this works. R minus 1. R minus 1, and I need both of them here. So R minus 1, R plus 1. Okay, so cancel out your denominator and go from there to solve. Okay, I just want to show you how to set these up so you can attempt them. One more word problem. Okay, we got Wu Yi and Wima mow lawns together. Wu Yi works alone, could complete a particular job in 4.5 hours, and Wima could complete the job in 3.7 hours. How long does it take to complete the job when they work together? So again, you need to set up a fraction here. So Wu Yi, say that guy or girl, is going to have one job done in 4.5 hours. Okay. Wima has one job done in 3.7 hours. We want to figure out how long it takes them to work together to get that job done. Okay, so this would be this person's rate plus this person's rate is going to be equal to a new rate. And so you go ahead and solve that. All right, so again, to solve this, I'd put this over 1, get a common denominator. Here with decimals, it's a little bit different. So you could get away with multiplying by the other one like that. So I don't know what a common denominator is between 4.5 and 3.7. I know that I can just multiply those together and it'll get me about what I need. Okay, so that's what I would do. And then over here, I'm going to need both of those, 3.7 and 4.5. And then you forget about your bottom and solve across the top. Okay, so then you should be able to solve that one from there. It's pretty easy. Add these two together, then divide by that, and I'll get x equals something, and that'll tell you how many hours it'll take them to work together to get the job done. Okay, so these two word problems are going to be two that will possibly be on your test, something similar to these. So it's important to know how to do these, and it's important to try them on your homework. All right, so that concludes the lesson. Page 515 is your homework. These are your numbers. 33, it says to use Desmos. So I think you're supposed to graph two equations and figure out their solution. So when you're doing this, two equations, wherever they cross, that's your solution. So check this one out. It's just simple as plugging in Desmos. So try to work with that. And I would definitely get familiar with using Desmos here within the next couple weeks when we're ready for our project. Okay? So thanks for watching. Good luck on the lesson, and let me know if you have homework questions.